Hello everyone, and welcome back. In this video, I'm going to cover the sprites for the NES. So with that said, let's do this. Alright, and welcome back. So in this video, I'm going to cover the sprites. And we're still using the Nerdy Nights mirror website under week 4. We're going over the sprite section. We already covered the palettes. And we as well going to cover a little bit of, well, we're going to cover the week 5 multiple sprites, which is pretty much doing the same thing, but loading multiple of them. And here is in a refactored, optimized way, so you can run the code. But the main meat of this tutorial is right over here. So let's begin with sprites. So anything that moves separate from the background is made of sprites. So anything that moves within the background is a sprite. The background moves, but you're pretty much just redrawing frame by frame, and it's easier just to demonstrate like this. So here you see Mario and Luigi moving from the sprite. So this is kind of easy giveaway that there's a sprites. You can see they move separately, but it is easier to show you guys if you come here on the PPU viewer. And here I have the name table. Here I have the pixels that we use of the sprite in background. And here is the sprite viewer. So right now I have this Goomba over here moving across the street. Across this, well, kind of a street, this pavement over here. And you see them, it's made of multiple sprites. And you can click over here and display the amount of sprites in preview. Right now it's just the arrow key for players. If I play select, it's moving between player 1 and 2-player game. So let me just reset this game over here so you can see more sprites. Well, it reset by itself. So here it is. So Mario and Luigi, as you see, is made of 4 sprites. So all these enemies over here is made of at least 2, the shells, the Goomba. Mario of the tail is 3, so as you see over here. There you go. Now it's smaller. Mario is made only of 2 sprites. So it's moving within this so here's within this background over here. So this is moving within. That's what I mean moving within. The torso moves separately from the background, but you get the idea now. So sprites made of 8 by 8 pixels. Generally is made of multiple objects, like I showed the Goomba and the Mario over here is made of multiple objects, except this arrow key over here. And examples, I already showed the example, and the PPU has enough memory for 64 sprites, and the memory is separate from all the other video memory and cannot be expanded. And there it is. We can use more. That's a limited amount of saying you can only use this amount of sprites, but you can do a character bank switch or you can change our mappers over here. So there's a way to get more sprites going, but generally we're working within this constraint over here. Let me close this out. So that is what Sprite is right over here. All right, next up we have our Sprite DMA, which is the fastest and easy way to transfer your sprites to the sprite memory, and DMA is your direct memory access. And it just means that it's gonna copy a block of RAM from the CPU to the PPU. And I'm just gonna excuse me. Here is pretty much the code, and I'm gonna go over it after I gone over here with the sprite, and this is pretty much go hand in hand, so you can show the purpose of this. But generally, you want to start at position 200, and it's gonna fill 64 bytes. This is gonna be FFF, and to do that, all we do here is set the low byte to this PPU port over here, and set the high byte to this PPU port over here, and gonna copy all the data that we need over here. And like I said, it's going to say all 64 Sprite Data sprites will be copied, like all graphics updates need to do during the start of the debug period. So this is going to be under the NMI. So this is a non-maskable interrupt that's going to occur at every frame in a way. and I'm just gonna go over it later. So right now I should go over the Sprite data and cover pretty much both of these together. But this essentially is telling the NES that their Sprite, all the Sprite data is going to be from the, in this case, at position 200, and then it's going to cover 64 bytes, which is 200 FFX over here. So let's go over Sprite data. So each sprite has 4 bytes, and it has all this information over here. It has a position, and the second byte is our tile number. Then it's going to be our attributes, which is right over here. All these bytes, it's gonna all of these bits over here in this byte corresponds to all this different functionality that we can use. And lastly, we have over here our X position. So here you have first is Y, so up and down, X, left and right. So it uses 4 bytes over here. So this 4 bytes represents for the first sprite. So the first sprite is going to use all these different bytes over here. And all the second sprite is going to use so the next other 4 bytes. So for example, at 200, you're going to use all this information, and 204 is going to just repeat over here, as that I was saying over here. So those 4 bytes repeat 64 times, 1 per sprite. That fills 256 bytes of memory. If you want to add a sprite 0, it starts at 200 to 203, sprite 1, 204, 207, and so forth. So let's just jump in over here in the Sprite ASM. So here is no maskable interrupt over here. You're reloading our byte over here. And here's our sprites, our single sprite. So here you load your palettes on the refactor code that we had over here. And here we're setting at position 80, which is right in the center of the screen. And we're starting that at 200. Then starting at 200 as well. So the center of the screen is going to be the X, and 203 is the Y position. From you see over here. So this is 0, 0. This is the first. This is the last. So 80 and 80. Then here's the tile number that we have. And here I just need a quick change to a bytes. You can use the percentage. Here's 1. No flipping, nothing, and store at the attribute table over here. So here's an enable the sprite for sprite 0 and so forth, enable sprites. So let's just do a quick compile code and run. Run Emulator. So here is our sprite right in the middle of the screen. So let's just, to the sake of demonstration, let's change this value over here. So let's start this. So over there, and let's do another LDA. Let's give it a value of, I don't know, 25. So let's run test. Let's compile code over here. So I can just close this and rerun. I'm just gonna quickly reload ROM. So it reloaded ROM, and this is where the position X right over here. So we changed the location. So from this 80 to let's put 45. Let's compile the code over here. And as you see, as a reload over here, it's changing the location of the sprite. Let's go back and leave it at 80. So 200, 203, that's X and Y. Next, you have the tile. Right now, it's a tile 0. If I come over here under your PPU sprite view over here, under your character over here, so there's your name table over here. If I want to, for example, let me just change the sprite colors because it's, so this is 13. Let me change this for, let me say, I don't know, 02. So let me just come over here. Let me see. Let me just do over here, just do a quick one. It's gonna change the actual values, but for now, this actually never mind. This is not important, but let's just come back over here under the PPU viewer, sprites. Here I have, character viewer. Let's change to one of these break values over here. So this is one is 86. Or I don't know what else can I change over here. 0, 0. So let's do this one. Let's change this for 0 to 50. So let's run tests. Compile your code. So we're expecting the 0, 0. So if we're to reload this ROM over here, here it is 0, 0. So we change that. And if you wanted the break before, so this is 86. So I've changed this to 86 over here. And do the compile to change your code. And reload over here. So here's our brick. So let's go pick another one for doing our attributes over here. What can we pick over here? What can we pick? Let's just go back to this 50 over here. So expect actually it's not that great. Uh, 40, 10. Okay, let's do this bowl over here, F3. Oops. F3, let me compile and check if it's actually put the right one. Here it is. Okay, perfect. And let's go over our attributes over here. So our PPU controller. Well, not PPU controller, attributes right over here. No, over here. So first is the color of the sprites. So this is the palettes that we can use from. So we have from, let me come over here. The palette viewer. So 0 over here is this first row over here that I'm going my mouse over. The next one is 1, which is right over here. This is the second, and this is the third. So right now I'm which one am I? Nicole. This is his first sprite. So right over here, come back over here. So this color over here, if I were to change over here, you can see the correspond for this one. So let's change for this one over here up top, which is 0. Come over the code, set it to 0. Run text, compile code. Let's reload over here. It's downloading, reload ROM. So right now I change that to the first palette right over here. And I can just change so as you see, I'm changing the colors over here. So that corresponds for this one. If I change this one as was before, nothing's changing. So let's actually just use the last one over here, which is going to be 1, 1. So the sake of demonstration, compile code and reload our game over here. And it's using this palette over here. As you see over here, I'm changing this color. So, go back. So this is pretty much using the bytes value. So that's 0, that's 1, that's 2, and that's 3. So 0, 1, 2, 3. So that's how we actually change the sprite combination right over here. So let's leave that at 1. I like this one better. Close over here. So the next up we have is our priority, front or back, behind the background. So there's and that's pretty much, you can use it to disappear. Not a good idea because it's still gonna have, if you render, have 8 sprites or more on the screen, it's gonna start flickering. So yeah, I don't want to put the background right now, so I'll show this later. And lastly, actually, let's see if that works. And that's the 5th. So let's 0 over here. Now I want to know if it actually works over here. So let me compile code. Let me see if it's gonna. Yeah, there's no background. No sprite background, so it's not gonna affect. So let's worry about the last two, which is the X and Y flip over here. So you can flip horizontally and vertically, either leave it on or off. So let's do a quick one over here. Let's run our test compile code below run. So that's the Y one. Wouldn't change much. So why don't you have a more unsymmetric sprite, but that's fine. Let's just reload this one. As you see, even though the Y position can change much, the X from this side changes. Let me see if there's a better one. Yeah, just put the sprite 0, which is Mario's head. So let's compile code. So now Mario should be flipped all the way to the opposite side. So here it is. So flip in a different direction, both X and Y. That's how you work all the attributes. So you have here the X and Y attributes and the tile number. And here I'm doing a position 200. So if I go back over here under our DMA over here, I started at this 200, but I can start at any position actually. I can just, I'm not going to change the 200 over here because from 0 to FFF is exactly all the memories that we need. For whatever reason, if you wanted to start at 205, you can certainly do it. But for sake of consistency, I just keep a 0. But I could change this to 300 over here. So run our task over here. Let's compile code. If I reload over here, nothing changes because this is now starting at position 300. So all of this has to be changed at 300. So that's what the DMA actually does over here. Let me just change it over here. So now if I to compile this, run test, compile, the picture should come back over here. Here it is, it's back. So that's what this DMA actually does, telling you where it actually starts. So it's going from this position, 300. So this is the low byte and high byte. So if I for 205, then it's going to be a 405. So a whole 64 bits over here. Let me just set everything back to 200 over here. Okay, that's fine. And that was because what was the first app? Is it week 3? First app, which is called background. Background, if you remember from the video, I was unaware why would this set you position FE at 300. That's why, because instead setting everything to, so in this case is position 300. In our case here on Sprites, if you come over here, setting at 200 FE. If I put FE on any of these locations over here, FE, that pretty much means it's going to be off the screen, so you're not going to see it. You're not going to see it. So if you compile your code, so right over here, but you reload our code is off the screen so you can see it. So in this part of the clear memory, FE, and we're going to start our DMA at position 200 because of this. You're essentially doing is putting all the sprites off the screen. So that's what move all the sprites off the screen. Of course, it's going to change everything from the attributes and the tile number, but you can also change those later. It's a good idea just to leave them off the screen regardless. So that covers pretty much the main sprites. So Go back to the sprites over here. And lastly, you have to turn on our non-maskable interrupt over here and your sprites on. So the PPU 201 used to enable sprites, which is 201. If I come to the code, is right over here. So enable or non-maskable interrupt. As I said in the last video, non-maskable interrupt should occur regardless if enabled or not, but that's what we're calling it. So we're setting that at the PPU port 2000, which is right over here, 2000. PPU control. So graphics are NMI at the start of the very blank over here, so set it on. So here's the other attributes for each representative bytes. You can change the name table address, or RAM over here, sprite patterns, 8x8, or background table address and sprite sizes. So I can change all of this over here under this PPU controller. So this is enable the sprite, and this is no intensity that we had before the PPU1. So come back to the code, and that's the whole sprite stuff ASM1. So now let's come over here and just go over this multiple sprites over here. Let's just go over this code. Let me just, oh, not you. Multiple sprites, that will be under controller, which contains both of this over here. And I have all of them over here already. The controller. So the code is essentially the same. All we're doing is load. So I'm going to go quick over this code. What is the logic of it? Oh, let me come back over here to the sprite. Okay. So we have this table load sprites, which we're doing a loop. So it's gonna come right over here. So it starts at 0, so in the beginning of the loop. Load sprites loop, so LDA, so we're loading the accumulator for sprites. And the sprite is down over here, so under your palettes. It's nicely done over here, space, so you can see this is the vertical value for sprite 0. Here's the tile numbers, attributes, and here is our horizontal, so it's changed over here. So it's gonna do that. So load 0, store at 200. Oh, so X is right now is 0. So load sprite. So it's gonna come right over here. 80. So 0. Store that 0, 0. X still 0, 0. So that's gonna first doing the actual is it X or Y? The Y location. Just forgot over here. First is Y. Back to the code. Increment X. So make sure it's less than 20. And then we're gonna keep going to the sprite. So next one, the X is gonna be incremented by 1. So going back here to the sprite. The next one is gonna be 32, which is actually right over here, our tile number. So loading the sprites from the sprite sheet. Viewer, so right over here is loading one of the sprites over here. One of this. Since it's 201, that's this doing over here. Then storing that at 201, which is going to change from 0 was X, was the Y location, and 1 is now the tile. Incremented is going to go forth to this one. So the next one is going to be the attributes, or the attribute value. Nothing's changed. So X is going to increment so again, and then going to put the horizontal, and that's sprite 0 done. So that's all of this is done. And then it's going to go back over here, 303, so it's going to be 304. And all the values is just going to keep loaded, and you're going to put the whole value over here. So if I come to run task over here, compile code, I don't know what I have, run emulator. Actually, this emulator is already running, so let me just close all this. instance over here, run emulator. So here is the whole Sprites actually loaded right over here. So it's the same thing that we had before. It's just a more optimized and cleaner way as well to run all your sprites over here. And if I want to come over here, PPO viewer, sprite viewer, all the sprites right over here. We have one more over here, which I think believe is off the screen. And that pretty much covers all the sprites that we need. In the next video, we're gonna go over the controllers. So how to read the multiple ports that we have over here. And whenever we get to the background, so let me see this controller next video. So the backgrounds, and I'm gonna cover these parts. That when I'm gonna show you guys how to actually change this our palettes over our palettes are well, actually I began one of my gaming let's say journey to this RPG maker, and that's where you had this sprite sprite sheets and whatnot, and all your terrain sheets and all different ones. And it's pretty much what it is. It's just I'm gonna change all of this when I get to this part. And I believe I'm just gonna show you how to make the sprites as well, not only the code. So that's gonna be for this video. Well, the video after. So the next video, you're gonna go over the controller so we can actually have some input for our games. And that's pretty much it. If you liked the video and all I've done so far, please feel free to subscribe. And I see you guys in the next one. Thanks and bye, guys.